So I'm going to talk about canceling long-running operations or asynchronous operations. These are things like callbacks, promises, futures, and everything else. So the small overview is, so what actually is the problem? Why you want to cancel operations? Then what's the current situation? And then how we can actually cancel uh, operations. So what's the problem? So we are making API clients, right? And all of the requests that you're doing, HTTP requests, are all asynchronous. You don't want to wait for a request to finish because that will make everything super slow. And if you then say, okay, we're making an API client, let's take a look at our GitHub. I want to find the one that an issue that I want to work on next. So let's say the oldest issue on the API client of JavaScript. So it's one about aborting search requests. So you need to figure that out. But I think maybe not. Let's find just the most discussed one. That's the same issue. So we do need to fix this, and we need to figure this out. So some background, JavaScript has always been very hard on asynchronous operations. So what it means, why? This is because JavaScript has always been single-threaded in a non-blocking way. This means, simply said, that if you are parsing a JavaScript program, or executing it at least, you will stop at everything which is asynchronous. Like, for example, a timeout, a request to another server, or other things like that. It will stop and then just continue while a whole loop goes on, and then if this thing meanwhile has been finished, we will continue there, and otherwise we continue with the rest. This is called the event loop, and we have three main ways historically how to deal with them: callbacks, promises, and async await. So let's go through all three of them. The first thing is callbacks. This is basically the oldest and has happened always for timeouts, for getting files, everything which takes time. So what we have here is we have a function, and as very last argument, we have another function, and its arguments are the error and the data. And then if there is an error, you need to handle the error. If there's no error, you don't. So that's what the if is for. And then otherwise, you do something with the data, whatever you need to do. There's something which is very important to consider here, as this is completely convention-based. It is all convention that the callback is at the last argument, is that the error comes first, and that it is null or a falsy value if it is not there. The fact that data or a million other arguments are after that is all possible, and that's kind of a foot gun. So because you can accidentally make a library which doesn't follow this pattern, for example, has the data first and the error second, because you think, why would I want a null value first? Which was actually what we had in our API client a long time ago. So after that, we had promises. Promises are basically a way how to make this more standardized. Originally, these were libraries, and then a spec came out of it, and now it's part of JavaScript as a total, as a language. So a promise is simply said something that you return from a function. So this function fetch will return a promise, and a promise has two methods, or at least two methods. One which is called then, which you can chain as much as you want, and which will have the data, and another one, catch, which will have the error, and then you can handle them as you need, as you want, and this will help you separate between the error and the data, and there's less convention, and there's more just things that are there, and otherwise there is a syntax error, which is nice. But the big advantage of having this as a language level construct is that you can go further with it, and you can make syntax sugar on top of it, like, for example, async await. Async await is simply said, you can mark a function as async, and then what it returns will automatically be a promise. And then inside this function, you can await as many functions as you want, and it will look like synchronous code, be simpler to read. Try catch is just like synchronous code, and there's no surprises really here. Now, let's go back to our problem and what do we really want? Which solution do we want? We want to cancel a running operation. Maybe we want to cancel multiple at once. That would be nice. And it would be very nice if we could do it from a separate code path so that you don't need to like call cancel on a promise, because that would be pretty annoying because you can only do it there. So the solution, which has been proposed mostly by Fetch, so Fetch is the way how to request data in browsers, is an AbortController. An AbortController is a new thing, a global in the browser, and in, not yet in Node, but it will be at some point, maybe. It is something that you construct, and this controller has a method called abort, which will abort everything. And it has a signal, another thing, which you can pass around and give to Fetch and give to other things. And then at the moment you actually abort, all of these will get an event that it is aborted and do whatever they want with it. And it will be a standard at some point. It's pretty close to it. So how do you implement it? This is how you use it. First, you make a new AbortController. You get the signal out of it. And then if you fetch, you just make sure that you pass the signal there. And later, if you abort it, fetch will abort. We will support the same thing in the new version of our JavaScript API client. So how do we actually support this? How do you make a promise cancelable or abortable? Is basically by accepting an abort signal, and this signal has event listeners, just like how DOM nodes have event listeners, and it will get an abort event the moment the controller actually calls abort, and then you can do whatever you need to pass to abort everything you need. In our case, this is mostly passing the signal down through to the fetch, which we use, but you can also, for example, cancel retry strategies and things like that. So the advantages of this way is that you can abort from somewhere completely different. You just need the controller. You can abort internally in your own method because you can just pass a signal around and send an error. And there's no need to extend the promise because that is bad for performance. The disadvantage is, of course, that it's way more verbose. Other solutions could be adding a cancel method to promise. You need to subclass it. It has the clear disadvantage that it is not standard at all and that people don't expect it. You can also use observables or reactive extensions, which are cancelable by design. And other programming languages, I'm sure, are handling it completely different than in JavaScript. So I'd love to talk about it afterwards. Thanks for listening, everybody.
So thank you for the presentation. So my question is, I mean, as a Node.js is single-threaded, or JavaScript execution in general is single-threaded, is there a priority regarding the abort calls versus the regular code that should run? Because I mean, is it possible that you call abort or you abort promise somewhere, but this part of the code is never actually called because other things in the event loop are executed before, and then you never abort. You will eventually, but
I guess this can happen with loads of other things in JavaScript. That's just something you need to take in account, that if your code does not get executed at any point, then your abort will also not get executed. So just need to take it in account.
so there is nothing that says when you abort, it's prioritized in the event loop compared to that.
No, it's just another API call. It's the big difference, the big reason why this is runtime rather than like something in the spec. Why Promise does not have a cancel method is because everybody has opinions and they just couldn't get this passed through TC39. So yeah, so that's how it's happening now. And you have, of course, the disadvantages.
So my question is this abort thingy just going to block the promise execution, or you can actually stop. So let's say I have a request that is going to download stuff, is taking too much, and I want to say just cancel it, just abort it.
That depends on the implementation. That depends on the browser. That depends also on other things, on how we implement it in our library. Basically, it could be possible that all the network request abort does is ignore what it returns. Could also be possible that it's freeing up the, the, the network stack, but we don't really know. That's just up to the browsers to optimize however they want. But I am pretty sure that actually aborting fetch does abort the whole network stack and everything to do with it, but I'm not sure.
What level is this in the implementation stack? I don't remember what it's called. Like, is it is it part of the actual spec of JavaScript, like
It's part.
ES8?
It's part of the spec of fetch, and fetch is part of the HTML spec, which is not part of JavaScript. So it is. It should be implemented by browsers. It is right now. There's difference between HTML and JavaScript. There's so it is implemented. I am pretty sure in both Safari, Firefox, both in the public versions, Edge maybe, and Chrome behind the flag.
Okay.